All right, so we are going to talk about the properties of logarithms. Recall that b to the m times b to the n, this is our exponent rules that we learned before, we added our exponents, so b to the m plus n. So we have the product rule here. Remember that the logarithms are an exponent, so the product rule is that if we let b, m, and n be positive real numbers, and again b doesn't equal to 1, then the log of b of m times n, we can become log of b m plus log of b n. So when it's multiplication, it will become addition. So the logarithms of the product is the sum of the logarithms. So think about it, it's multiplication, you rotate it becomes addition. So multiplication logs will become added ones. All right, and then recall that b to the m over b to the n is equal to b to the m minus n. So here we're going to subtract our exponents. So if we're looking at the quotient rule of logarithms, then we will understand that if they are, again, b, m, and n are positive real numbers and b doesn't equal 1, then we have log base b of m divided by n, they become subtractions. So you can think about this, you see that line right there, you're going to have a line right here, it is subtraction. So it would be log base bm minus log base bn. So those are going to follow our rules. Let's look at those and then we'll come look at the power rule. Let's do some examples. So this is 4.3 and example 1. We're going to use the product rule to expand a log expression. So use the product rule to expand a log expression. Remember, again, that's a logarithmic, but we're going to call it log just to make it easier. So part A, we have the ln of 7x. This is multiplication, and remember, those logs can be the natural log or a regular log. So this is the log, but an ln is a log, it's just a natural log. So this becomes the ln of 7, because it's multiplication, plus the ln of x. Notice that both parts get an ln. All right, let's look at b. So if we have the log of 10x, then that is the log of 10 plus the log of x. Now sometimes you might have to simplify this. Remember, if they don't show you the base, it is a base of 10. And whenever you have just a number, you might need to look at that. So log base 10 of 10 plus the log of x. Well, if we think about what we've already learned about exponential, if we change this to exponential, 10 to what power gets us 10? Well, that's 10 to the first power gets us 10. So that means that this is 1. Also using our exponent rules, we know that if it's log base b of b, where they both match, which this does, the 10 and the 10, it's going to equal to 1. So 1 plus log of x, because you might need to do some simplification there. All right, let's look at example 2. For example 2, we're going to use the quotient rule to expand a log expression. All right, so part A, if we have the log of x divided by 2, this will be the log of x minus the log of 2. This is a base 10, so we don't have to worry about it reducing down. All right, let's look at B. So if we have the log of base 7 of 19 over x, then we have the log base 7 of 19 minus log base 7 of x. For part C, we have the ln of e to the third over 7. Well, this will become the ln of e to the third minus the ln of 7. This is where you have to remember that the base that's on here, ln's are a base of e. So now we have ln base e to the 3. So if we go back and look, if we have the ln of e to a value, to an x, it's going to be equal to that exponent of x, because those e's will, as they follow the process of just what we looked at on the previous one. So in this case, this will become 3 minus the ln of 7. All right, let's go to the power rule. So on the power rule, if we let b and m be positive real numbers, with b is not equal to 1, if we recall the exponent rules, we learned that b to the m raised to the n is equal to b to the m times n. So when it's being raised to a power, we are going to multiply the exponents. So this will be log base b m raised to the p. The p will come out front. So it'll be p times log base b m. All right, so let's go look at an example of this. So example 3, we are going to use the power rule to expand a log expression. Alrighty, so for part A, we're looking at the ln of x squared. So what we need to do is bring our exponent out front, and this will be 2 times the ln of x. For part B, if we look at log base 5 of 7 to the 4th, we're going to bring our 4 out front, so 4 log base 5 of 7. And remember that the base of these logs is not on the same level of log. It's dropped down just a little bit. It is a subscript. All right, part C, we have the ln of the square root of x. Well, we have to rewrite this with an exponent, so we end up with ln of x to the 1/2, which will equal 1/2 ln of x. So we have to bring the exponent out front. Part D, if we have the log of 4x to the 5th, that will be 5 times the log of 4x, because we just bring it out front. All right, so let's go look at the properties of logs. So on our properties for expanding logarithms and for condensing logarithms, we're going to go ahead and look at both of them, and then we'll do some examples. So for our properties for expanding log expressions, given that m and n are greater than 0, means they're positive values, because we can't take the log of a negative number, log base b of m times n will get us log base b m plus log base b n. So that's our product rule. Our quotient rule, again, is log base b m over n, which is equal to log base b m minus log base b n, which is our quotient rule. And log base b m to the p equals p log base b m, which was our power rule. So the properties for condensing logarithmic expressions, so that's expanding, we're going to go that way. Condensing, we're going to come back the other way. So if it's addition, it will become multiplication. If it's subtraction, it will become division. And if we have a number out front, we have to move that up first. Note that the coefficient must be a 1 before you can condense it. So you can't have a number out there to condense first. You have to move that. So the power rule will always be the first step you're doing when you're putting it back. All right, so let's go look at example 4. So for example 4, we are going to expand a logarithm expression. And we're going to use multiple properties on these. So for part A, we have the log of base D times x squared, the square root of y. So the first thing we need to do is change that square root into the exponent of 1/2. So that'll become log base D of x squared y to the 1/2. So as we expand these, we're going to work on our properties here. So the first thing we're going to do is this is multiplication, so it's going to become addition. So log base D of x squared plus log base D of y to the 1/2. Now we'll use our power rule and move our exponent out front. So 2 times log base D x plus 1/2 log base D of y. And if you look at this, you can see if we were going to condense this back, the 2 would come back up, the 1/2 will come back up. The addition becomes the multiplication, and then we can change the y to the 1/2 back to the square root. So going backwards would be a way to condense this, just so you're becoming aware of how these work. All right, let's look at part B. So for part B, we're going to have log base 6, the cubed root of x over 36 y to the 4th. So this will be equal to log base 6. We need to change the cubed root of x to the 1/3 over 36y to the 4th. So in our expansion, the division becomes subtraction. So we have log base 6 x to the 1/3 minus log base 6 of 36y to the 4th. Now 36y to the 4th is a multiplication, so we need to expand that with addition. So log base 6 of x to the 1/3 minus log base 6 36 plus log base 6 y to the 4th. Now I put that in parentheses because this whole thing has to be subtracted. But I'm going to go ahead and do the addition so I can follow the rule, and then I'm going to apply the negative to it. The other thing I have to look at here, I have all numbers here. 6 to what power gets you 36? Well, 6 to the second power will get you 36, so this will become 2. And we also need to move our exponents. So this will be 1/3 log base 6x minus, this is going to become 2, 6 squared equals 36, so minus 2, and we're going to also subtract this one and bring our exponent out front. So minus 4 log base 6 y. So that's how we expand. Let's go do some condensing using our condensing rules, which means we're basically going to go backwards. So for example 5, we are going to condense log expressions. And of course, we're using those properties again. So for part A, we have log base 4 2 plus log base 4 32. Well, addition means multiplication, so we will get log base 4 of 2 times 32, and 2 times 34, or 32, will get us log base 4 of 64. Well, 4 to what power gets us 64? It is 3. So we can actually take this all the way down to like a final answer. They won't all go that way. But in some cases you will. So you just have to really pay attention when you're doing your homework. So if we have, for example, B, 2 ln of x plus the ln of x plus 1 is equal to the ln of x. So the exponents have to come first, so we're going to put the 2 back up, plus the ln of x plus 1. All right, so first thing we had to do was our power rule to get, because you can't expand or condense it until you have a 1 up front. So we moved that exponent up, and now this will become multiplication, which will be the ln of x squared times x plus 1. Part C will be the log of 4x minus 3 minus the log of x. So this one we haven't written a base. We know that this is base 10. So this is subtraction, which means it will be division. So this will get us log of 4x minus 3 divided by x. And that's all you're going to do on that problem. That is completely condensed it. All right, let's go look at a bigger condensing problem. So this will be part D. So for part D, we are looking at 4 times the log of base dx minus 2 times the log of base d6 minus 1/2 times the log of base dy. So the first thing we have to do is move our exponents up, back up there on our variables or our numbers, depending on what they are. We need to put those back because we have to have that coefficient of 1 before we can put them back together. So this will become log base d x to the 4th minus log base d 6 squared minus log base d y to the 1/2. So when we see those two subtractions, if we go back and look, if you remember on example 4 part B, we had two subtractions, and that was because they were both being divided on the bottom and they were multiplied before, so they were a plus. So we're going to do that same process and put these back together. So we're going to take those two negatives and bring it out to just one negative and put an addition in. So log base d x to the 4th minus log base d. Now this is 6 squared, so I'm just going to write it as 36 plus this is log base d y to the 1/2. So basically I pulled out the negative sign and made that addition. So now this can become multiplication. So log base d x to the 4th minus log base d 36 times y to the 1/2. Now we have subtraction, so this is going to be on the top and this will be on our bottom because it's going to be division. So this will be log base d x to the 4th divided by 36y to the 1/2, and y to the 1/2 can be rewritten as log base d x to the 4th over 36 square root of y. So that one's a little bit longer in all the steps that you need to take. All right, the next thing we're looking at is the change of base property. So the change of base says for any logarithmic bases a and b, any positive number m. If we have log base b m, we can change that to b if it's a base that we don't know, like the calculators don't really know, because the calculator can do base 10, but if it's a different base, it cannot. So what we can do is take and switch it to the same base, so log base a of m divided by log base a of the b. So the m comes up here and the b is down here, and they're the same. So the logarithm of m with base b is equal to the logarithm of m with any new base divided by the logarithm of b with that new base. You've got some change of base things you can look at. Basically, we're talking about the same kind of thing here. So it's going to be the base here, or it can also go to both LMs. So the ln of m over the ln of b versus the logs. Because as long as it's the same base, you'll get the same answer there. So we're looking at change of base. So we're going to use the change of base property. So for part A, we have log base 5 of 140. So we're going to do log of 140 over log of 5. And you're going to put that in your calculator. So using your calculator, this is your log button right here. So you're going to put in the log of 140, close your parentheses, divided by the log of 5. And then you'll get your answer. So it's going to be approximately 3.07, depending on what they're giving you for values, or decimal places. All right, we could do the same thing using the ln. So we could take the ln of 140 divided by the ln of 5. So if we put that in the calculator, here's our ln button. The ln of 140, close your parentheses, divided by the ln of 5. And we get the exact same values on our calculator. So it's still 3.07. So it's because they are the same base. ln's the same base of e, these are the same base of 10. So you can use different ways to do it. All right, let's look at another value. So if we have log base 7 of 2506, this would be the log of 2506 divided by the log of 7. And when you put that in your calculator, you should get 4.02.